Okay, this is the tutorial about how to run Klipper and what it does. You're looking at my desktop. Very boring, I'm sure. Klipper here in my pull-down menu is something that I have put into a very specific location, Animation Projects. You can see it here. And it's C Animation Projects, and it's then under Klipper. First thing you'll see in Klipper is it's got its own info file. It's got klipperinfo.txt. And the reason that this klipper.info text file is so important is these text files are the backbone of Klipper. And you should have the same thing when you run Klipper. I've also provided a kind of mock project, and that is called Geistfaust. And this Geistfaust project is again in the same place as Klipper's in Geistfaust, Geistfaust. Both Klipper as well as Geistfaust have areas that you can jump into to see info files. Klipperinfo.txt under Klipper, and under Geistfaust you can actually go into a folder called info, and it has information that we'll get into later. The first thing to look up into is that in the klipperinfo text file, it houses all the information about all the various projects that you may be running in Maya. In this case, I've got Geist here. But please be aware that Geistfaust is actually listed below as the full project path. We list the full project path here. So when I type in Geistfaust, Klipper knows exactly what I'm talking about and sets the current Maya project to be dealing with the Geistfaust project. I find that when I deal with things that are command line driven, I try to make them as easy as possible. So I also included within this same text file an alias up here, so that you can simply type in the word Geist to mean Geistfaust. So when we evoke Klipper, it says Maya path, and this is very important up here. This is the first thing to verify when you run Klipper, is that it's currently finding the Maya path to Maya 7. Down here at the very bottom is how I align how to find Maya, set Maya path. And I've got things here for 6.5, 7.0, 6.0, and at the very bottom I put in 7.0, which is in a different location, see program files alias Maya 7, than this version of Maya 7 here, which is CAW Maya 7. So you want to make sure that you've got your current version of Maya running in this area of the Klipper info text file. And when you first evoke Klipper, it will verify it by saying it up here at the very top line. If it can't find it, it will complain to you. So the first thing we do is we type in GIEST, and it says, okay, I've found that project, because it says it's setting the active project, Geistfaust, the project path. It regurgitates that and lets you know that the Maya path has also been found as well. So what does it find now that we are in actually in Geistfaust? Well, the first thing it's going to do is it's going to look for the characters.info file. Now, what does the characters.info file? The characters.info file is something that lets you know how many characters, what uniquely named characters are in this scene. And in this case, we've got the Geistfaust, which is a Ghost Fist, and we've got the little brother character, Rude Kid, Scared Woman, and Toilet Wraith. And every time I list these characters, I list their root. And what does that mean when I say that I list their root? It means that when Klipper starts doing the production pipeline processes of baking animations and cutting and pasting those animations onto rigless characters, it knows exactly the top root it's looking for. Going through this tutorial, I will assume a modicum of knowledge about Maya and baking characters. If you don't know what the baking the characters means, then you can of course go to these various tutorials that I've already put online that talk about the baking process, so I don't have to go over it here in this tutorial. But suffice to say that every time a character is cited in this information file here, characters.info, we list not just the character, but we also list the top node of that character. and we list what Clipper needs to go through to cut and paste onto a rigless character once it's done baking. And the second part is props. And the reason that props is important is because sometimes there are multiple props within a scene that are not skeletons, they are actual geometry, and they are constrained different ways. So in this case, we've got something as basic as a knife that's parent constrained, but down here we have something that is actually a lattice, and we have scales and things like that. And these get a little tricky, so I wanted to make a separate info file here for all the various props that people can do and put up within their scenes, and they have very unique ways of being constructed. Anyway, into scene 1, SO1. Go in here, we type in SO1. It says, okay, I'm setting the scene to number 1. Now Clipper knows that everything I type is going to be dealing with Geistfaust, and it's going to be dealing with scene 1. We go into scene 1 in the info file, and we look at SO1, CO1. Because I've split Clipper into understanding that every scene is SO whatever, and then clips are CO whatever. You can have everything from scene 10, S10, to 1 to 99. So it could have SO1, CO1, or it could have S99, C99. Every single one of these clips has a corresponding information file. And why is that? Well, that's because what happens in these files is that I describe globals. These are the global areas, such as starting frame and end frame. In this case, it's 1 to 20 because it's just a test file. The output format is JPEG. The extension padding is 4. And all this stuff is a constant, regardless of whether I'm rendering a low res or a high res. In the successive areas here that are delineated by these little marching ants, I have an animatic, and it gives the image name and path, i.e. the location where Clipper will render these frames, whether the renderer is software or something like, say, Mental Ray, which is indicated down here in the high-res area. But while we're here in the animatic stage, everything is very simple. Motion blur is turned off, depth map shadows are off, anti-aliasing is 0, and the scene itself is actually quite simple. It's only currently the camera because it's not been filled out correctly. And also, of course, the size, Y and X resolution, the height, and the width, very tiny, 320 by 240. As we get into the low-res area, well, things kick up a notch. It's 480 by 270. We now start getting into more complex scenes, and by the time we get to the high-res area, we're at 480 by, well, usually it's something like 640 by 480, and we've got motion blur on. You see mental rays now being utilized, so we've exponentially upped the amount of render time that's necessary to complete these things. So the first thing I want to do in the demonstration is to show exactly what it is that we're dealing with when we deal with Clipper. In this case, we've set the project to something called Geistfaust, but what does that mean? Well, let's take a look at some of the scenes and see if we can't sort of unravel what's going on. So here's a copy of Maya. I'm going to go into Geistfaust here, and I'm going to render in a scene SO1, CO1, low characters, and this is where all the characters lie. Everything has this structure: SO1, CO1, low characters. Could be S99, C99. Again, it would still be low characters if we're dealing with a specific character. Why this is because the actual file that has everything in it is at the top. This is the scene that we're dealing with. This has everything. I'll just color code it here. What we've got is we've got a rig of the scared woman going up against the wall. Yikes! Yikes! Look at that. Let's turn everything off except for, say, polygons and the control curves. So you can see that this is a proper rig, and she's a scared woman. Well, what if one of the first things you'll notice is that this is not just a rig of a scared woman. It's got several things in it. It's got spotlights. It's got backgrounds, bathroom, back wall geometry, things like that. How do we incorporate all these into Clipper? Well, again, when we bring up Clipper, one thing I can say is CO1, scared woman low. What Clipper is going to do in this case, and I'm going to put in a -V for verbose. What Clipper is going to do is it's actually going to take this scene SO1, CO1, and bake this woman out, and then cut and paste her into, look up here, the base file. And the base file is where we keep all copies of characters that do not have rigs. So scared woman here under low wire, and again this format is the same everywhere. Scared woman low wire. We deal with her rig, but we're looking to cut and paste the animation from the rig onto something that is rigless. In this case, it would just be this character here, and you can see pretty quickly that she does not actually have anything like a rig. She's just a simple skeleton that has various geometries actually constrained to the bone. So it's a super simple setup, and what we're looking to do is to cut the animation from, well, to bake the animation from this complex scene of rigs and lights and whatnot, and bake it onto this character that does not have a rig. So I save it originally as CO1 low, SO1, CO1. What Clipper is able to do is to go in and use something we call shortcuts. And each of these here, scared woman okay, by the way, notice this little icon here in the lower left hand corner is actually a shortcut. And how I do it is I do this. I say create shortcut, and then I cut it, and I go into characters and I paste it. And then what I say here is I actually rename this to scared woman okay. It has to be an okay file. What this does is it allows me to have multiple characters referencing the same file. I can read in SO1, CO1, and change several characters that could be in it. Right now this is a very simple scene, it's only got one character. But this scene could have several different characters. It could have, say for sake of an argument, 4 different characters. Well, under characters here, since I only want to bake one character at a time, I want to create a shortcut per character and then name it that character's name _OK. Why do I do that? Again, naming convention, so that when we go back to Clipper, I say CO1, scared woman low, and -V. Clipper understands we're dealing with scene 1. It now understands we're dealing with clip 1. We're dealing with scared woman. We're dealing with the low res, and we're dealing with verbose. So when I do this, and I say run, 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 and do so in verbose, it lets me know, okay, I'm going to be grabbing the scared woman okay file. I'm now baking it. We put very explicit steps. I'm cutting and pasting it now onto that rigless character we saw, and I'm saving it. So this has been completed successfully. Let's go in and take a look at it. When I open the scene, scared woman, this is under base. We don't want base. Base is kind of where the originals are kept. We want to go to the specific scene and clip that we're dealing with. Under characters, and scaredwoman.ma is the final file. Let's take a look at that, see how that looks. Well, I don't see anything right now, but oh, there she is. Let's change the camera attribute editor to be something reasonable, not that, and not that. There we are. Lovely. Okay, well there she is. She looks like she now is a very simple character, just that, no rig, no constraints, and she's actually moving for the duration that we assigned to Baker, which is only 20 frames. If you remember us going back into the info file, we said at the top that this only deals with 20 frames. If we want to change this and go to the full range of motion, let's read in the original file. In fact, I'm going to do this just to show you how it works. Get rid of that and rename the shortcut, because that's how it should be. So let's read in the shortcut, because as we know, it'll read in the original file. We have about 150 frames here. The camera goes back. We can change this. 150. We save it, and then boom, we rerun it, and suddenly the animation is going to bake the entire range to 150. Now the reason I've done that is because production work is iterative. You do these things again and again and again and again. The reason I parted all of them out is because you may just deal with 1 out of 4 characters for days, if not weeks. You don't want to muddle with the other characters, which is why I've parted it out. However, you do want to have one big file to change things in, so that when you change Scared Woman and you read her in, you're actually reading in the much bigger file up here, which is SO1 CO1. You don't start changing one character and then you have multiple files. Everything is essentially a shortcut to a main file, and when you change one thing, then we're solid about it coming from one source. So Klipper bakes things, which is kind of cool. The other part that Klipper does is, as per the info file that we showed, it can amass the entire scene description language for something that you want to render. In this case, we look down here under low, and we see that it's going to be reading in camera, Scared Woman, and back wall. So how do we make sure that that happens? We do this, CO1 SDL low, and I also want to put in -V for verbose. This lets you see how this thing is amassing all these objects. It's actually referencing them in and saving it as a scene description language. Well, what does that do? Well, we go in here to the SDL file, and we go in here to SO1 and read in SO1 CO1 low, and lo and behold, when we read it in and go to the proper render camera and expand this out to 20, we have the very same shot that we originally had. Again, the original shot was out to 150, so here we'll do that just to show you. But look, there's a much less complex set of things. We have the camera, we have the Scared Woman, we have the geometry. That's all we need, because each of these individual things has been saved out as a separate file into the proper area. This was baked by Klipper just now. This was saved by hand, and this was saved by hand. But we were able to read all these 3 things in very quickly. And now we're able to render it. This is all saved as one SDL, scene description language, by virtue of Klipper putting all the separate models together using this part of the info file, objects within the scene, and using this command, CO1 SDL low -V. I like -V because it lets you check. You can also run SDL low. Here, it doesn't really bore you with the details of what it's doing. It just kind of tells you, okay, I'm doing it, now I'm done. It also does the same thing for Scared Woman low. If I do not put a V on there, notice that, again, it's just not descriptive as to what step it's at. So I use -V, not as the default, so that when you want to start debugging something, well, then you can. So now we're at the stage where we can say something as complex as render low. But before I do that, I want to bring people up to what Klipper exactly is doing every time you run a command. We're in the info file. Now let's go into the SDL file. You see it's saving scene description languages, but it's doing so with references. So things are very tiny. This is only 7 kilobytes. Yes, of course, the models themselves were not that complex, but the reason that I'm using referencing is so that anytime I change anything, it's automatically updated here in the scene description language. I could change Scared Woman low and start rendering instantly, knowing that this is a reference that refers to it. And also these collections of Maya files are much smaller when they're not actual geometries read into the scene, that they're simply references. Anyhow, what Klipper is actually doing is it's going and creating a MEL file every time I type a command in here, and it puts it into the temp file, TEMP, so as not to interfere with Maya's default temp file, TMP, and it makes this temp.mel. And what it does then is it just kind of puts in a custom-built MEL script, copy animation, animation copy and open, copy anim, etc. And then it executes this on the fly using something called Maya Batch, which is a version of Maya that runs from the command line without the UI. So this whole thing is kind of an emulator that emulates a Unix environment that will not only let you do these iterations using small vernacular nomenclature to not only cut and paste animations, but to then amass the entire scenes as well as render them all together. And what I wanted to point out is that in the temp, every time you run Klipper, it makes this mel file here in the temp directory and then executes it. That's how it's able to accomplish what it's able to do. But we're entering an area that's a little sticky now. It's fairly clear what's going on here. You can just follow the mel script. A great way to debug these is to go and open mel up, read these files into mel, and see what kind of errors you get, as Klipper is not very descriptive when it comes to debugging. However, when we get into the render area, one thing I want to make clear is, and we'll go up here to renders, SO1, CO1, there's all these below. There's all these frames that have already been done. You see that that's just the render of the woman kind of backing up, and there's only 20 because that's all we delineated. If you were to delete the render file and then start this render, it does one of two things. First of all, it goes in the temp directory and does not write a mel script, although it says mel. This is not a mel script. What this is an actual DOS command. At this point, it's actually render.exe. It tells explicitly where to go, and then it gives all this description about exactly what type of render and where and what to name it and how often and how big, etc. And it puts it down there, and then it makes the computer start rendering. This is actually rendering as we speak. That is because I also want to show something else within Klipper, which is, as we've just seen, it makes the render directory if one does not exist. So we can now jump into SO1, CO1, and low, and actually see on the fly these things being built, and these images being rendered. And the point is that the faster the machine you have, the more this is going to render automatically. And it's a great way to kind of catch up and do multiple renders at once. What Klipper's built to do is not just one command, but several. And you can just line them right up one after another. And I'll show you how to do that because we've done them one at a time here. But I want to show you how to actually set something up so that you're able to do several commands at once. A bit of a bug here. It says the render did not fail. The render failed. Obviously it did not, because we're looking at it and these renders are all good. So here is how we actually run several commands at once. And I won't start the render again. But it does show you that you can, using a semicolon, say Geist semicolon, SO1 semicolon, CO1, STL low semicolon, and it actually does them all sequentially. And then at the very end reiterates your original commands and says succeeded, 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 etc. So Klipper is a very clever little program that allows you to do full production all the way from cutting and pasting animations of characters to amassing entire scene description languages, i.e. STLs, all the way to rendering, and to keep all this information not at the hands of the user, but within an info file so that you can do these multiple passes in production and not sweat the small stuff. You don't actually have to know the frame range for something to render it. All you have to know is type in, clip 1, clip 2, clip 3, whatever, ren low, ren high, ren anim, things like that, and it will render this out. So that is basically the tutorial on Klipper. It's a pretty nice little program. Make sure that you are that you have the info file within the Klipper directory pointing to where all your projects are. Of course, I like to use C animation projects as my default for not just Klipper, but all the projects I'm working on, including the one we used here, which is Geistfaust. So if you're using this same address, you should be good to go. All right. If you have any questions, get a hold of me. Other than that, happy Klippering.